So it's kind of strange to think about this, but in the beginning, people weren't even sure that air was even really there. And they had some weird ideas about what exactly it was. But by the 18th century, we had pretty much determined that air is actually there and that it is a mixture of gases. It wasn't long after that before we started to put that knowledge to work and develop things like hot air balloons for travel. And with our modern understanding, we have some contemporary issues, including things like ozone depletion in the stratosphere, where we lose this layer of ozone, which is a type of like oxygen molecule that helps protect us from the sun, and carbon dioxide release into the atmosphere that's causing global warming and climate change. So, gas pressure. Pressure is not just a quantity that gases have. It's defined in physics as any force divided by area. In gases, gas pressure is a result of the force exerted by gas molecules colliding with the surface of objects. In the English system, the units for pressure are pounds per square inch. And one measurement tool that we use is called a mercury barometer, and this is a device that's used to measure the atmospheric pressure. You have to kind of conceptualize pressure a little different than force. In this example here, you have an elephant, which is really large, very massive. It has a lot of force pushing down, but each one of those forces, all that force is distributed across its 4 feet and touching the ground. And that actually exerts the same amount of pressure on the ground as a small ice skater who is balancing on just a single skate. All of her weight is being forced down into a very small area on that ice, and that pressure is actually causing the ice to heat up and melt, which is what lets her slide across the ice. So let's talk about some of the units of pressure. Sometimes, due to the way that we may measure pressure, millimeters of mercury is a useful unit for us to use. Far more commonly, you're going to see atmospheres, where 1 atmosphere is like the normal atmospheric pressure, the pressure that we're experiencing all around us all the time. When we're working in the SI system, the unit for pressure is going to be the Pascal. This is defined as the pressure exerted by a zero point 0.1 millimeter high film of water on a surface beneath it. And that's a really small unit, right? That wouldn't exert a lot of pressure. So we often work in kilopascals or 1,000 pascals. Another related unit of pressure is the bar, where 1 bar is equal to 100 kilopascals. And then we have our pressure conversion. So we can see here that 1 bar and 1 atmosphere are really close to one another. That's also equal to 760 millimeters of mercury, which is equal to 760 torr. Torr and millimeters of mercury are therefore the same unit, which is equal to 14.7 pounds per square inch, psi, which is equal to 101.3 kilopascals. Using these pressure conversions, we can move between whichever units we want, to making conversion factors.